Hey everyone, I'm Becky the Science Tutor, and today we're diving into the world of solutions, specifically concentration. Have you ever made a really strong squash drink or added too much sugar to your tea? That's all about concentration. It's how much of a substance is dissolved in a liquid. And in this session we're going to have a look at how to measure and calculate concentration and why that's important in chemistry and in real life, and how it affects reactions. So let's get started. Okay, so first of all, let's think about what is concentration. So as I said in the intro, concentrations is the amount of substance that is dissolved in a certain volume. Okay, so it's the amount of substance dissolved in a certain volume of solution. So if we have a lot of substance in a small volume of solution, we're going to get a high concentration. So when you'd put that bit too much squash into your drink, bit too much in the glass, added the water, we've got a lot of the substance in a certain volume, and therefore we've got a high concentration, probably a little bit too tangy. Now what we're going to have a look at is how we calculate concentration in terms of thinking about the mass of the solvent, so how much in grams we have, and the volume of solution. Okay, so here we've got calculating concentration. This is in grams per decimeter cubed. Now with any calculations, and especially if you've seen other videos of mine where we look at any form of calculation, I talk about specifically making sure that you know what units that each of your parts of the equation need to be in, and what units your answer needs to be in. So if we are given calculate the concentration grams per decimeter cubed, we need to make sure that our mass of solute is in grams, and that the volume of our solution is in decimeters cubed, so that our answer comes out in decimeters cubed. So I've got an example for us to have a look at here. So it says, what is the concentration in grams per decimeter cubed? So I know that I need my answer in grams per decimeter cubed of a solution of sodium chloride where 30 grams is dissolved in 0.2 decimeters cubed. So the first thing I'm going to do is just check, are my units in the right size? Yes, I've got grams and I've got decimeters, because quite often volume can be given to you in centimeters cubed, where we would need to convert into decimeters before we substitute into our equation. So this one is nice and straightforward. Okay, so we're going to take the concentration. So concentration is the mass over the volume, and if I substitute that in, I've got 30 divided by 0.2. I'm just going to move my answer units so I can put it all in one nice neat row. So if you pop that in your calculator, you're going to find that you've got 150 grams per decimeter cubed. Okay, let's have a look at another one. So this time we've got what is the concentration, and again we want it in grams per decimeter cubed, of iron chloride solution where 10 grams, that's okay, is dissolved in 25 centimeters cubed. So at the moment my units do not match. So I need to first of all convert that 25 centimeters cubed. I'm going to divide that by 1,000 to get that into decimeters cubed. So that gives me 0.25. Sorry, Mr. Zero, I'm ahead of myself. 0.025. Let's delete that and start again. 0.025 decimeters cubed. Now I've got decimeters cubed, so now I can substitute in. So my concentration is the mass over the volume, which is 10 grams of iron in 0.025. Again, I'll just straighten that up so it lines up, and that will give me 400 grams per decimeter cubed. Now, by using this equation and rearranging, we can also find the mass of a solute, so we can work out how much do we need to dissolve to produce that particular concentration. So if I just concentration first. If I just put my equation here, so mass is the what am I doing? I'm rearranging it already, aren't I? Just brain ahead of the game. The concentration equals the mass over the volume. I want to come back a step and show you the steps through it. So if I substitute that in, at the moment I want to produce 80 grams per decimeter cubed, and it asks me what is the mass. So I don't know the mass at this moment in time. And the volume, again, I've got 20 centimeters cubed, but it's asking me for grams per decimeter cubed. So I'm going to do 20 divided by 1,000 to give me 0.02 decimeters cubed. Now I can substitute that in, 0.02. So to find the mass, I'm going to have to do a slight rearrangement. So if I times both sides by 0.02, that will enable me to find the mass. Therefore, if we pop that into our calculators, should find that we need 1.6 grams of copper chloride to give us a concentration of 80 grams per decimeter cubed. So you can see that this calculation allows us to work out, well, how much do we need to dissolve? If I need this strength, I'm going to need that much solution, or I'm going to need that much solute. And so we can interchange that equation and work out the various parts. So let's have a look then at a couple of questions and what we would do with those. Okay, so here then, we've got vinegar is a solution of acetic acid and water. The concentration of vinegar is typically 0.05 grams per centimetre cubed. This means that in every centimetre cubed of vinegar there are 0.05 grams of acetic acid. Calculate the mass of acetic acid in 100 centimetres cubed of vinegar with the concentration of 0.05 grams per centimetre cubed. Now, yes, this is in grams per centimetre cubed, but if you look at our answer, it's wanting the answer in grams, and therefore we don't need to convert. As long as all your units match, then you can continue as it is. If we had a concentration that was in grams per decimetre cubed, and we wanted the answer out in grams, because our grams per decimetre cubed doesn't work, we'd have to change that around. But because it's okay, we can go ahead. So the concentration is 0.05. We need to know what the mass is, and we've got a volume of 100 centimetres cubed. That comes from the question there. Okay, so multiply both sides by 100. Okay, and that will give us that we need 5 grams dissolved in 100 centimetres cubed to produce that 0.05 grams. Okay, I've then selected this question to show you here. This is calculate the mass of the acetic acid in 0.2 decimeters cubed with a concentration of 0.025 grams per centimetre cubed. So we're going to need to convert somewhere along the way. Now if I try to convert that 0.025, if I was to simply divide that by 1,000 to get into decimeters cubed, it's also going to alter my grams. So the easiest thing is for me to change the decimeters cubed down into centimeters cubed, and then I can continue as normal. So I'm going to do 0.2 divided by 1,000. Oh, bear with me. I hope you spotted that. Multiplied by 1,000. Sorry, I'm going the wrong way. It's not very often that you need to convert the other way. Okay, so 0.2 times 1,000 is going to give me 200 centimeters cubed, and then I can continue with it as normal. So my concentration is 0.025. That equals the mass that we want to find over the volume, which is our 200, and therefore when we rearrange that, multiply both sides by 200, 0.0025, and that gives us, I'm going to tap that one into my calculator, my mental maths is not that fast enough for that one, and so that gives me 0.5 grams. Okay, so how will that look in a exam question? So here's a typical exam question, and you can see because we are asked to calculate mass, it is a 3 mark because we need to rearrange that equation to find that mass. Okay, so we've got the student used a solution of sodium hydroxide with concentration 4 grams per decimeter cubed. Calculate the mass of sodium hydroxide in 25 centimeters cubed. Again, these don't match. It's easier for me to convert the 25 because if I change the decimeters to centimeters, I'm going to be altering the grams as well, and I want my answer in grams. Okay, so I'm going to convert that 25 first. So I'm going to do 25 multiplied by 1,000 to get that into decimeters. Did you spot it again? Probably losing the plot today, aren't I? Nope, that's not quite gone. Delete that. Divide by 1,000 gives me 0.025. Trying to use my mental maths. Guys, don't use your mental maths. Use a calculator, so you don't end up losing those marks. So there's my decimeters cubed. Okay, concentration equals mass over volume. I'm going to come down here. I know the concentration, that is 4 grams per decimeter cubed, equals the mass divided by the volume, which I now know is 0.025. So I'm going to multiply both sides by 0.025, and that will give me my mass of 0.1 grams. So in terms of marks available, we've got 1 for our conversion, 1 for our correct substitution, and then 1 for the correct answer. Okay, let's take a look at another one, so a bit of a higher level question here. So the difference here now, we've got 4 marks available because it asks us for our answer specifically to 3 significant figures. So we can forget about that for the moment. So if we think it's a 3 mark question, do our calculations exactly as we did before, and then we'll worry about mark number 4 by getting us to 3 significant figures. So we need to calculate the mass of potash needed to make 800 centimetres cubed. So again, we've got a difference in units. So 800 divided by 1,000 is going to give us 0.8 centimetres cubed. Okay, now I can put concentration equals mass over volume. I know the concentration, I want to make 258 grams per decimetre cubed. Mass I want to find, and I've got a volume of 0.8. So if I times both sides by 0.8, oops. Okay, and I'm going to put that on a separate line, show you for why in a second. 258 equals, I've got 206.4 grams. So that gets me mark number 3. However, it wants me to give it to 3 significant figures, and therefore down to 3 significant figures is 206, which will gain you mark number 4. Okay, now the next section of this is for higher tier students only. In terms of calculating concentrations, if you are a foundation level student, you will only ever be asked to do it in grams per decimetre cubed. If you are a higher level student, you are asked to calculate in moles per decimetre cubed. And so in this section now, we're going to have a look at how we calculate in terms of moles per decimetre cubed. Okay, so as you can see, we've got the same principle. Concentration is the amount by the volume. The only difference this time is that our amount needs to be in moles. Okay, so if we take our first example, it says what is the concentration? So we need in moles per decimetre cubed. So we'll start with the simplest first. It says we've got 2 moles in 500 centimetres cubed. We need to convert that centimetres cubed into decimeters. So we're going to do 500 divided by 1,000, which gives me 0.5 decimeters cubed, and this one is nice and straightforward to start with. The concentration equals a number of moles, so 2 moles divided by 0.5 decimeters. And that gives us a concentration of 4 moles per decimetre cubed. Okay, so let's take it up a notch. Okay, so here we've got what is the concentration in moles per decimetre cubed of a solution containing 3.7 grams. So because here we've got 3.7 grams, we need to convert that to moles. So we're going to have to bring in our moles calculation as well. Okay, so we're going to need our moles equation. So moles is the mass divided by the MR. So we're going to need to work out the MR of that calcium hydroxide, CaOH2. Okay, so using your periodic table, you're going to look up the masses. Calcium is 40 plus 2 times 16, because we've got 2 oxygen. And then we've got 2 hydrogen because they're in the brackets. Now it doesn't matter how you do this. You might add 16 and add the 1, so do 17 times 2. Yeah, how you go about it is entirely up to you. Okay, so I might say that I'm going to do 2 times the 17, and that is going to give me an MR of 74. Now I've got my MR, I can find the moles. So the moles is the mass that we have got. So we've got 3.7 grams. And we're going to divide that by the MR, which is 74. And therefore we have 0.05 moles of calcium hydroxide. Now we've got our moles, we can put it into our concentration equation. We're in decimeters cubed, so we don't need to do anything further. So concentration is the moles over the volume in this case. So we've got 0.05 divided by the volume, which is 0.25, and that gives us a concentration of 0.2 moles per decimeter cubed. Okay, so let's have a look at one final example then, so where we work it the other way to find out how much solute was dissolved in a solution. So this time we want to find out what is the mass of sodium hydroxide in 0.4 decimeters cubed of a 0.6 molar solution. So first of all, we want to find the number of moles in the solution. So if concentration is moles over volume, we're going to need to rearrange this to find moles. So our moles is concentration times volume. So we've got our concentration of 0.6 multiplied by our volume of 0.45, and therefore we can work out that we've got 0.27, oops, I don't know why I put an extra 7 in there, 0.27 moles. Okay, and now we need to convert that to mass. So that is using our mass equals MR times moles. Yeah, we know the moles. We're given the MR in the question. Therefore, we're going to find out that mass equals MR is 40. That's given to you up there. They've already worked that one out for us. Multiplied by the 0.27. And we can work out that that's got 10.8 grams. Okay, so that's how we can interchange again to find out the mass that we would need. So just to finish off then, let's apply this to a couple of exam style questions and what it is that we need to do. So this is a more straightforward question because it is worth 2 marks. Everything is given to us, we have just got to substitute that in. Okay, so let's have a look at what we've got. We want to calculate the mass of sodium hydroxide in 20 centimeters cubed of this solution. Now we're given the concentration decimeters, so we're going to need to convert that first of all. So 20 divided by 1000 gives us our 0.002. See what I mean? Don't use your mental maths, just use a calculator. Because in your science exams we are not testing your mental maths, we are testing if you know what to do. So that will be in decimeters. Okay, so this is our volume. Concentration equals mass over volume. We're wanting to find the mass. Okay, so we know the concentration. Trying to think where to write it so that it's not all too squished up for you. So 0.18 equals the mass that we are trying to find over the volume, which we just calculated is 0.02. Okay, so times both sides, 0.02 times 1.8. Absolutely cracking up me at the moment, aren't I? 0.18. You should tell maths is not my strong point, therefore I have to work it through incredibly methodically to make sure that I get the right answers. Okay, and that comes out at 3.6 times 10 to the minus 3. Okay. Whoops. And one final one then, guys. Let's just make that as big as we can. Okay. So calculate the mass of sodium hydroxide in 30 centimeters cubed of a 0.15 mole per decimeter cubed. Well, first thing to do, get rid of that centimeters cubed. So 30 divided by 1000 equals 0.03. Decimeter cubed, that's our first thing, and then we can work out how many moles that we have in there. Let's remember that our concentration is moles over volume, so our concentration is 0.105. that equals the moles over the volume, which is 0.03. 0.03 times 0.105. Oops, thought I missed my decimal point out there. 0.03 times 0.105. So let me just write this down as an intermediate. It doesn't matter whether you do it write it in standard form or you write it out at this moment in time. So we've got times 10 to the minus 3. This is moles. And then we want to calculate the mass. So moles times MR. So I'm just trying to lay it out so you can see exactly where I've gone next. We're given the MR in the question, so times 40. And that should give us 0.126 grams. Okay then guys, hope you found that helpful, and as always, if you need any further support, don't hesitate to reach out, and I'll see you next time.